Alright, so buckle in. We're going to go over a pretty serious topic here that seems to be kind of not being properly addressed across the industry. Today we're going to try to be understanding dairy farm sand recapture systems. Understanding sand for bedding. Primary reasons a farmer should want to use sand as bedding is it's inorganic, which means that bacteria and stuff don't typically stay on it. Helps, keeps cows cool, obviously, and primarily also comfort. We know that pretty much sand, by everybody's standards, really is the best bedding. As far as a bedding goes, we're not just talking about mats or anything right now today. We're talking about sand bedding, okay? Primary pitfalls of having sand bedding is the number one problem is it destroys equipment. Listen, if you ever talk to anybody who has a farm with sand on it, you know that all the equipment is in danger, and a lot of these systems that are being designed do not necessarily take the equipment in mind. Inorganic doesn't mean disease and bacteria can't still live on it. So this is another misnomer, right? So like people think, oh, I have sand, it's inorganic, I can just put it in my barn, no problem. But we can see systems that are improperly designed and where sand is not drying out properly, and we just have these huge explosions in the barn, with cell counts, and people are always like, well, I was using sand, but okay, well, you didn't let it dry, you didn't properly collect it, and that leads me into the next point is that more labor is needed to properly manage. So if you have sand, or you're wanting sand, and you want to redo your farm to sand, and or build your barns with sand for bedding, you need to understand that there's a lot of labor that goes into it. Okay, not all sand is equal. So we'll just go through what sand should be. It should obviously be clean. So whatever source you're getting your sand from, you need to make sure that it's not really contaminated. You should definitely try to wash your sand before you put it into the barns, because a lot of sand, when you just get it from, well, for example, the guy who's bringing you sand may not necessarily wash out his truck, and he may have just had a whole load of like clay or silt prior to bringing you sand, right? And the problem with these two things is that that bacteria loves them. So if you don't wash the sand or have it washed, you definitely are bringing in sand that could potentially cause disease. We should look for medium and coarse texture sand. And the reason for this is because it does provide good drainage. Like you hear people talk about sand for comfort. I've heard so much talk as far as like people trying to find finer sand or whatever. This isn't necessarily the real issue. The real issue is we want to be able to drain away any moisture that can get on top of the bed where she's going to lay. Obviously moisture helps bacteria, etc., and disease grow. We should definitely look for angular particles again, because health-wise for a cow it provides better traction and stability. It's going to reduce slips and injuries. And if you can find high-quality silica sand in your area, this is definitely recommended because it's super durable and consistent. Now you may not be able to find all these traits in sand, specifically this last three, but you definitely need to make sure you're getting clean sand, and you definitely want to make sure that your sand is going in the barn without a bunch of clay and silt in it. Okay. So what's needed to move sand? So flushing should be the number one way that you're collecting sand out of cow lanes, and this is because when you're scraping sand and you're moving sand with a scraper and or maybe let's say I've seen a lot of these barns that are put on the wrong slope, and so therefore flush water doesn't move the sand out of lanes because they're not getting enough velocity, which we're about to go over, and then so therefore they're having to scrape 2 or 3 times a day. Well, the problem with that is that you're now mixing in the sand with the manure every time you scrape. And this is a problem because when it just goes straight into the collection ditch, and then all of a sudden that collection ditch is 90 feet or 100 feet, however long that your collection ditch is in your barn, and it's in a funnel, it's in a tunnel basically, and the sand and the manure don't have an opportunity to actually start separating while they're in that ditch. And so now all of a sudden there's this introduction either through like a flush flume or some sort of way to push the sand and manure out of the ditch into a lane. Well, the reality of that is that then when that happens, the separation of manure and sand start only at the point of the sand lane. Whereas if I'm flushing, the minute that that flush valve opens, it starts interacting with the manure and sand and starts moving them into different water columns, right? So it keeps the manure is lighter, so it's going to float more on top. The sand's going to find a lower part of the water column to be in. Even when it goes into a collection ditch, which we're about to discuss why that's not necessarily the best idea, the best way to collect sand, okay? But if you do have a collection ditch, and this is what's happening, well, even still, the sand is still going to find a bottom quicker than the manure, but it's all one fluid motion, right? So, how to move sand with flush water? Well, we know that finer sand on level lateral surfaces requires a minimum of 1.45, which in Manning's law we should have at least a 0.013 condition of our concrete, and obviously Manning's law is expressed as this equation. But the reality of it is that cow and truck lanes are not flat surfaces as they're grooved for traction, right? So we not only need to flush the water to lift the sand and manure mixture off the lanes, we also need to force these debris up and out of the grooves to along the moving rate, which won't cause slow drying, which makes lanes slippery and hazardous. Meaning that we need our water column to be moving at a rate of which we're about to go over, at a rate fast enough that it's actually going to air dry quicker, so that when the cow steps out of her bed, she isn't just moving into wet slippery lane, right? Because the slower a water column moves, the longer time it takes for the surface to dry. We all know that's science. It's vital not only to move the waste and the sand debris out of the lanes, we must also ensure that we don't create long-lasting slippery conditions. Therefore, to move not only the manure/sand mixture debris, which oftentimes the sand we're using is not finer sand. We have a much heavier manure sand mix that sees the flow required to move it to increase to at least 2 meters per second to effectively evacuate the sand kicked out of beds by cows, right, into the lanes, if the lane had no grooves. However, most of the lanes have grooves. Therefore, we should increase the flow of the flush to a minimum of 3.25. This will ensure that a fast water column to increase drying time will effectively lift all of the waste off of the lanes and out of the grooves, right? If we have a flatter slope barn, this means we're going to have to use more water at each flush to get there. And if your barn was properly designed for sand, if you're bedding with sand, you should be using a minimum of 2.25% slope, right, when sand bedding is present, to ensure the least amount of water required to effectively clean the lanes. And that's the reality of this, right, is that's why these barns that have been put in that are flatter to have the sand bedding, the sand's not getting moved out of the lane, so they're having to go in there and manually scrape it. It's because it's too flat and there's not enough water being pumped out, and they don't have enough water storage to pump out, into the lanes. We're talking about if your barn is on a 2.25% slope, you need, 2.5 minute flush to get the thousands of gallons that we need, about 6,000 to 7,000 gallons that we need to actually flush that lane. If your barn's on a 0.75% slope, which believe me, there's actually being built like that, which is idiotic when you have sand and you're trying to flush, you need at least 11,000 gallons. So now you're looking at, about a 5 to 6 minute flush, which they're not doing, okay? So what now? We know how the lane should be cleaned. What really is the best way to recapture sand? And how much sand is collected, right? So we'll get into diagrams here in a second, but this is the reality that we need to understand that is not being told or isn't being understood out there in general, right? And the truth is, on average, a cow will kick out about 8 pounds of sand a day out of her bed, or 3.6 kilograms a day. Sand in most climates needs 28-day drying period to properly dry and to use the sun to help disinfect it, okay? The sand isn't just out there drying. When we're moving it and turning it, we're actually using the sun's UV rays to help disinfect the sand so that whenever it goes back into the barn, it's free of bacteria and disease, right? So how do you calculate the sand stack pads, right? Sand stack pads need to be equivalent to this formula, okay? I want you guys to screenshot this. Everybody should use this. This is the truth. There's not a lot of knownness out there about this, right? You don't hear a lot of people talking about how they're sizing their stack pads, but this is what you should size your stack pad. Trust me, okay? So you take your number of cows times the 8 pounds a day they're going to kick out times 21 days. This allows for 28 rotation days plus 1 process days, right? Equals the number of pounds to be stored. We know that there's about 2,200 pounds in a metric ton. So, and then sand piled no higher than 4 feet, okay? No higher than 4 feet should the sand be piled, with an average, diameter of 1 foot at the top and, 1 by 1 slope cone down to a base of about 16 foot diameter. So this will give us, each one of those piles is going to give us, a volume of about 287 cubic feet or 16.2 metric tons. And the base area of each one of these piles is approximately 201 square feet. So let's run through an example formula. We have 500 cows times 8 pounds of cow a day times 21 days is going to give us 116,000 pounds, that's going to be on this sand stack pad somewhere, okay? Divided by 2,200 pounds to give us 52.72 metric tons, divided by 6.2 metric tons in each pile. For 500 cows means we're going to have about 3.25 piles at an average size of 201 square feet, which is going to give us about 655 square feet of storage required, or surface area required, concrete surface area required for these piles, or 61.75 square meters. Okay. Therefore, if you have 5,000 cows, so 5,000 divided by 500 is going to give us 10, a multiple of 10 of this, right? So it gives us 6,550, sorry I couldn't get that out, or 6,175 square meters, okay? You also need to allow oversizing of about 15% for equipment movement and runoff area. In other words, your sand doesn't need to be, your sand needs to, when it's drying, needs to be in an area that's never going to be influenced by the water traveling through the sand collection lane, okay? And equipment should have an unimpeded 360-degree access to the piles, okay? You can't just, and we're going to go over a system that you should not be doing and a system that you should be doing, and you'll see the importance and the reality of why your equipment should have an unimpeded 360-degree access to piles, okay? So again, screenshot this. This is what you should be sizing sand stack pads for whenever you're using a sand recapture lane, okay? Now I'm going to show you a couple of examples that one is being installed, which is just extremely bad, and two, one that I just did for a farmer that we will go over and have a better understanding of what that system looks like. So let's go over this system. So this is actually a system that's being installed in places, and I'll just tell you specifically, I've seen them in Australia. He's probably doing them in other places. This is absolutely horrendous. They're going around telling people that this system can do anywhere from 100 to 5,000 cows, okay? I'm going to tell you why that is a lie, not just because of the system itself, but because there is no actual reality that this system could be doing 5,000 cows, okay? 100 cows, 500 cows, maybe even 1,000 cows, but 5,000 cows is no way, shape, or form, right? Not only that, we're going to discuss why it's such a bad system for collecting, trying to recapture sand, okay? First off, the sand and the water is being caught over here somewhere in a collection ditch and is being flushed in a pipe, who knows how long. I mean, every one of these little farms vary, but the pipe is, making turns and all kinds of stuff. And again, every single one of these dairies, the barns were put on a flatter surface than they need to be, so therefore they're scraping into the collection pit, also while trying to use flush. So that means all of the crap and the sand is in this, ditch down here, and it's just waiting for flush to then push it through these pipes. Because it's so, who knows how even long it sits in the bottom of the ditch between flushes, right? It has time to cake onto itself, and so as it's being pushed through these pipes at sometimes too small a volume and sometimes too fast a volume, what's happening is it's coming out of these pipes, and because it's not entering a channel right off, it just has this, they just have this one lane, so the section of this thing kind of looks like this. Here's the pipes. There's no channel that it's entering into. The water is just coming out. It just has a right, and it's not being managed. It just flows up this little hill here, and then you see all kinds of organic matter and debris, to start collecting on this supposed drain pad, right, where the sand's supposedly stacked. But and then it moves out of this, and then because it's not being directed, what happens is the water and the sand, and it's being flushed, and it's all caked together. It's super turbulent, so it just makes this weird turbulent pattern before even ever getting into this area where it's, you know, it's supposed to be pretty much, it's supposed to be laminar the entire way, so that you know, as I'm you know, sitting here, so let's say that this is the top of a water wave, if you will. If the water is laminar and not turbulent, well, you know, I'm going to help keep those particles of manure on top, and then you're trying to keep, like I said, those particles of sand in this lower water column, so that these keep moving down the road, and then the sand itself, because it's heavier, will float down to the bottom if properly sloped, okay? But because it's coming out with such force, it never has a chance to really become laminar in the primary area where they're trying to recollect sand. So I've seen all these sand piles that they're collecting, and every one of them is just filled with organic matter, okay? None of these farms that I saw are old enough to really have you know, a super impact just yet of the sand that they're going to use. But the reality is there's no way they're collecting the 80 or 90% good sand that they need in order to make having a sand recapture system profitable and or, you know, worthwhile, okay? Another problem with this is that, you know, they had this little entry ramp that comes down, and there's these huge stem walls all the way around. These walls are huge. Every one of these walls are, you know, typically 4 or 5 meters tall. It's just insane to me, right? Just a bunch of concrete and just a storage area that, you know, in here is only 221 square meters. Okay, this is actually very kind. To be honest with you, it's probably closer to something, you know, along this regard, because so much debris is just getting in here. But I was kind, and I gave them, you know, more of an area. But realistically, they probably only have about 178 square meters. Furthermore, you know, this front-end loader, this is a true front-end loader size, has no way to actually come in and manage the sand from either side. You know, we're basically only stuck from this degree and this degree, and of course it has to back up into here where all that, you know, junk. Obviously it's trying to collect sand from here, but it's just a bunch of organic material is in here. And if you've ever been to one of these, you'll just go pay attention. You'll see that just this whole thing is just lined with organic material. Furthermore, because it's not laminar, what's happening is it then tries to come in here, and it's super turbulent, and it comes in here and it builds up these like ramps of like sand and manure that's been compacted together because again it got collected into a ditch, and then they're trying to flush it out. Well, what happens then is then you have these farmers, you know, that are like, bless their hearts, they're trying to like put in these hoses extra water to try to, you know, get these ramps on or dislodged, right? Worst case of this whole thing is that then the sand, because there's a bunch of sand that's not getting collected, it's just moving into this area, and it's coming into, I can't really tell if this is a wannabe sand trap or what have you. This is not the proper dimensions of a sand trap, by the way, and that's the reason why on these farms, this one farm that I went to had so much sand in this collection pit. It was like, oh my God, how in the world are you going to get all that sand out of there? I'm not even kidding you. I don't know how deep this pit was, but it had to at least be halfway full of sand. And these pumps, bless their heart, I mean, they might end up having a lifespan of 2 years, maybe 3 years. But worst case of this whole problem is now it's pumping all of this, you know, dirty, nasty sand that's not been properly separated into these earthen basins, okay? And then they're trying to get water to then flow into this pond. There's no real staging. If you saw this pond in real life, you'd be like, oh my God, that water is so black. I mean, you know, it's so nasty. Also, like, look, and then what they do is they have these, you know, pumps that are then pumping back into the barns, okay? They're then pumping back into the barns. But look, you should never do this. You should never have this draining directly to where this is going to be pumping. Ever. Never, ever, 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 ever should this be going on, okay? Ever. You should never, ever, 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 ever have this be the pump house where this drains into that, right? realistically, they should have had at least the pump house over here, okay? It's still not ideal, but the pump house is right here, right where these sand, these earthen basins are draining. You got like little slide valves here that are draining into this pond, okay? So, horrible system. And you cannot collect, if you have a 5,000 cow dairy, this is not going to work for you, ever. Number one, the lane is not long enough. Number two, you don't have enough area to, stack your sand and recapture it and let it properly dry. I mean, this is enough, 178, square meters is, maybe enough for, let's go back and look at our formula here, right? So we know that 61.7 square meters is needed for 500 cows. So we can do 178 divided by 62, so times 2.8, 500. At best, this is 1,400 cows. At best. But again, you're losing a lot of movement in here. So realistically, this gets even smaller because your dozer or your front-end loader, is going to need this area to actually move the sand. So, again, horrible idea. There's no real sand trap in here. Sand is just moving straight into these collection pits and then just being pumped into these earthen, basins. This is an environmental nightmare. It's not only bad for your cows, it's bad for the land. These ponds have no freeboard, nothing. This is a horrible, horrible, horrible system. And the people, I don't even mind. The people that are putting this in should be blasted day in and day out because this is a horrible system. Okay? So what should it look like? Here we go. And we'll just come here and we'll go to, we'll go here. So we'll start with what should be happening in the lanes, okay? First off, in the lanes, we should be moving, in this barn, I have the water moving at about 3.4 meters per second. This is fast enough that, the water's going to move, the sand's going to move, the manure's going to move, and there's no settling out, okay? We have these little transition pieces at the end of the barn. I mean, this is just a concrete thing. We don't really ever want sand in a sand recapture system to go into a ditch, okay? So this is actually a better way. So lane to lane, all right? So lane to lane is what you should be doing. Not have it dumping into a ditch, because what happens when we dump it into a ditch, we're just, causing that sand and that manure to then remix, where the manure can't stay on top of the water and the sand can't stay in that lower water column. Okay, so then it moves into this next lane, and we want it still moving pretty fast. We want to have some nice curves here to where the sand doesn't hop our curves and get out of the actual lane. So then when it comes through and it's moving through, we need it moving at about 2.6 meters, and then it's going to transition in this little transition piece, and we're going to start slowing it down, because what happens with this other little system, is the sand, it's just coming at who knows how fast, right? Sometimes it's too slow, sometimes it's way too fast, and so it never has a chance to really truly start settling and make those nice laminar columns that we want to be seeing within our water, okay? Our water and our water columns, because we want the manure floating on down the road, and now the sand moving and settling in this lane, right? So we then slow the sand down. Now it's moving into this lane. This lane, here's another misnomer, right? Not all sand that you're going to collect should be reused. By the time this is the sand that gets captured in this lane, maybe a little bit into here, is going to be pretty good sand to recapture, and we're going to stack it up over here nice and neat. We're going to have an area where we can move in with our front end loader, we can move out, we can use this push wall to help get more moisture out of the sand by stacking it up. And then as it comes around, we can increase the speed just a little bit more, because by the time the sand's getting here and the manure is getting here, the sand will still be falling out at this rate, but the manure will still stay on top of the water column, and we'll start getting more bad sand, and we want to move into a true sand trap, okay? An actual, real sand trap. Not this, I have no idea what they're doing here. I don't even think this is a sand trap. I think it's just a lane, and it just goes in, and I have no clue, to be honest with you. I didn't see the section of this thing. I know what this section looks like, and it looks like this. which again doesn't impede the water at all. Okay, or help the water become laminar and move on down the road, and keeping the manure on top and the sand in the lower water column so it can drop out. All right. Now here's a true sand stack pad. Okay, and we'll show you the section here that it looks like. Right. So we have our non-reused sand area. This is what the sand lane should look like. You should have about a 250 meter curve right here, easily for any equipment, bobcat or front end loader to move into. Our stack pads, probably look like something like this. We have a curve here so that, water from the outside gradient doesn't, necessarily come in. And that way, this is nothing for, this loader to come in and actually, move around, and has access actually even from here to influence these stack pads. So again, we have a nice 360 degree, we have a nice beautiful push wall, and we have an area to stack our unusable sand, which you should have, right? So sometimes you'll have water coming in from and/or sand being collected from like your parlor. Well, we probably don't want to realistically are going to want to use that for different reasons, so we're going to want to have that piped in here to this sand trap. Again, this section through this, looks like this. So here's your sand lane, here's your sand trap, here's your collection tank. Obviously, you have an overflow rear, fencing, etc. So this is realistically the best way to collect sand. It's lane to lane. Sand is moving at a nice high volume, flow rate wise, to get out of the barn, get the lanes nice and clean. Keep them through these transition lanes, and then we're going to start slowing it down. We don't just want it to go like it does over here, right? So in this system, it just comes right out and slams on the brakes, right? We don't want to do that. We want to help it transition its speed down so that, again, there's still the inertia to keep the manure on top and the sand start to settle out in these lanes. We don't want these big, wide, 6-meter lanes either. This is insane. You should never have a lane that's 18, 20 feet wide, okay? Your lane should be, at best, at max, 4 meters, okay? 4 meters. 4 meters. 4 meters, okay? And maybe sometimes even narrower depending on some of the situations that we have as far as land use, okay? So then, realistically, by the time all of this happens, because it's proper, we're not getting any sand in this collection tank. No sand. So your equipment is going to last forever, okay? The equipment's going to last forever. You're pumping, but also you should be having emergency overflows coming out of your tanks, okay? And because the reality of it is that this may all fail. So we still need water to evacuate to the pond, okay? And when it moves to a pond, I'll just show you, realistically, you should be doing, when we have these systems, we should be having basins, more concrete basins at stage 1. And this is not a very, very deep pond. This is just to settle out most of the solids in here. So this should be more, there should be more advocacy of this in the industry, that our stage 1 pond should be concrete because it'd be super easy to clean out. And then our stage 2 pond, realistically, is still a solid separating part of our waste retention or wastewater retention. And these ponds, realistically, should still have some sort of concrete apron that, where this pond is sloping to here so the solids can, gather, okay? So, again, this is being pumped. Again, we should have systems in place if these separators are down or something's happening, open this gate valve, and so we can then pump into here in case these separators aren't working, right? Well, or here's that overflow that we were talking about coming into here into, as an emergency overflow in stage 2. So, the truth of the matter is that this system is very different than this system in a whole lot of ways. And the reality is that this system might be okay if you got a few hundred cows, okay? That's why a lot of them are being put in with these barns, and they're telling these farmers you got like 300, 400, 500 cows. Oh yeah, you can do up to 5,000 cows with this. Well, it's impossible. You don't have enough. You don't have enough storage area, okay? you don't have enough area, right? So this farm had 1,000 cows it's milking. So look, we got about 6 piles that are going to be on there, and plus we're going to have, a non-reuse pile, okay? But there's going to actually be about 6 piles of sand, if not, smaller sand piles, that are going to be drying as we're collecting for those 28 days, okay? And again, this is true to scale, front end loader that's, moving these piles as needed, using, push walls as needed. We don't have this huge, waste of concrete where I have these huge, right here, massive, stem walls, which, I have no idea if they designed proper or not. I mean, they may fall in on the farmers. Who knows? I don't know what they engineered it by. But one final point on this system. So here's a bridge that's moving into the truck lane, right? So this is a pretty great aspect. This way, when you're feeding, you're coming into the truck lane. You're never touching, slurry water or anything like that, as we're using this lane-to-lane system for sand recapture, okay? So, you have a nice groove ramp, comes over, a nice traffic bridge coming down into the truck lane, and this is a true section through the barn, right? So just in case you were wondering, well, hey, how do you get through that truck lane without dragging all that crap into the barn? Well, there you go, okay? So I hope this was helpful in the end. This is what you should not do. This is an example of what you should do. Okay, feel free to use it. I mean, if you have, feel free to reach out if you have questions. If you're wanting to, design a sand lane, or you have, a farmer who needs help with their sand recapture system. Maybe they have one that's in place, but they're not actually recapturing that golden marker of 90% or better. Okay, which this system right here will. Then, absolutely, let's chat. I hope you guys have a great day. Again, I just strongly encourage everyone to stop allowing this to be built, because, again, just even this part of the system is a horrible idea, okay? Just even this part. There's no staging in this. Anyways, it's a horrible system, okay? I promise. It's just, this is better, lane to lane, give enough of a slowdown so it isn't just, coming to this area and then causing all this weird turbulent water and, all this organic material to just be planted up here on the stack pad, okay? So, cheers, guys. I hope everything for you guys is going well, and best of luck with you and your girls.